which came in the common paper, which you all have. Okay, so I went over that question on proofs on terms as well. Okay. All right. So this question is from your textbook. That's exercise 3, first question. Now, before I carry on as well, I just want you to go over the proofs of the 3 theorems on parms. Okay, they are in your textbook. You just go over that, right? So here we are given a parm, actually 2 parms A, B, C, D. Okay, so we have got A, B, C, D. That's our first one there. Close the top window for me. Okay, A, B, C, D. Then we also have A, B, D, E. That's A, B, D, E. So those are the 2 parms. Now, please, whenever you are coming to a test which involves geometry, I would encourage you to have colors because you might need to highlight shapes. Because if you try to do it in your head without seeing it properly, you can end up making mistakes. So always use a highlighter to highlight the shapes that you are given. So here we are given those 2 parms, A, B, C, D, and A, B, D, E. All right? Now remember, if they are parms, it means AD is parallel to BC. Also, AB is parallel to CD. Furthermore, AE will be parallel to BD. Now, for CD, if CD is parallel to AB, it also means that CE is parallel to AB. Because remember, last time I told you that points like this, E, D, and C, if they are on the same straight line, it means we call them collinear points. It means that the gradient along that line is the same. Therefore, CE is also parallel to AB as well. Okay? So make sure you are aware of that. So I can indicate here in the same color because they are the same. Okay? So, and we are also given that DF is equal to DB. So DF is indicated there. DF is equal to DB. So we are supposed to prove that BCFE. So let me highlight that. BCFE. So that whole shape there. We need to prove that it's a parm. That whole shape. Okay? We need to prove that that whole shape is parm. Alright? Now, before you think about answering this question, you need to ask yourself, which property of a parm are you going to use to prove that the quadrilateral is a parm? So you have to think about the property first. Okay? Now, in my case, because that quadrilateral BCEF, it has got diagonals inside. If I can prove that the diagonals bisect each other, okay, which means I just have to prove that ED is equal to CD. I'm already told that BD is equal to DF. Okay, that's given already. So the only thing that I just have to do is to prove that ED is equal to CD. If I can prove that ED is equal to CD, I'm almost halfway through because I'm already told here that DF is equal to DB. So I'm going to prove that BCFE is a parm based on the diagonals that are bisecting. Okay? Because if you want to prove that BCFE is a parm, then you need to think about which property first. Okay? So I've decided that, okay, because there are 2 diagonals already in that quadrilateral. It's not a parm yet. There are 2 diagonals. If I can prove that the diagonals are bisecting, then it means the quadrilateral is a parm. So how do you do that? First thing, let's write the fact that DF is equal to DB. And this is given. Okay, that's given. So that information is provided for us in the question. Okay, then the next thing now is for me to prove that ED is equal to CD. Now, it's not that easy to directly prove that DE is equal to CD. So what I'm going to do first, I'm going to say AB is equal to CD. Okay? Because ABCD is a palm. So I can say AB is equal to CD. My reason here will be opposite sides of the palm. Okay? That's the first step. Then the next thing, since ABDE is a palm, it means AB is equal to DE. Okay? And my reason here is the same. My reason there is the same.